Going on now to learn in lesson 1.6, simplifying and evaluating algebraic expressions. We're going to start off by doing some vocabulary building. These are the objectives. Now to start us off, and this looks rather confusing, so we'll go to our whiteboard and we want you to put in your notes background and then basically copy this as we go along. So first of all, what are like terms? Well, like terms by definition are terms that have the same variables to the same exponents. So as we look at this listing of terms here, there are no like terms. But let's give you some examples. If we had 2AB and a negative 4BA, would these be like terms? Well, our definition of like terms, once again, is the variables are the same and they're to the same exponents. Well, as we look at these, there doesn't seem to be any exponents. When there isn't an exponent by a term or a variable, there is a 1 actually written there. So all of these, this 2 has a 1 exponent too. We don't write the 1s. So in a sense, this is b to the first and a to the first. The orders in multiplication is not important. So these would be like terms. And also what I want to mention is what is a term? By definition, a term in an expression, as we see here, is separated by either a positive, and in this case we don't have any negatives. I could change that to negative, but that's what defines terms in an expression, separated by a plus or a minus. Now, what are the parts of a term? Well, the words we're going to use is the coefficient. Now, let's look at this one here. 4x to the third. This is a term. Now, the parts of this term is the 4 is the coefficient. And we often use the word numerical coefficient. Now, this means 4 times 3 x's. The variable, of course, is the letter that's with the term. And then on this letter, there is an exponent. Now, the exponent on the variable will determine the degree of the term. So let's look at this expression up here let's see, change the colors here. Let's use a dark blue. What would be the degree of this term? Well, we look at the variable. It's to the third power, so this degree is 3. How about this one? This one is 2. This one, again, doesn't seem to have an exponent, but there's actually a 1 there. So this is 1. Now this doesn't have a variable, so in a sense we can think of this as the degree of 0. Now let's just do these while we're here. What's the degree of this term? Well, again, it's the sum of the exponents on the variable. Well, there's 2 exponents, so this degree is 2. And since these are like terms, this degree is also 2. Now, how about the degree of an expression? And the answer you should write down is the highest degree of any one term. So as we look at this term, 3, this is 2, this is 1, this is 0. So in this expression, what's the highest degree of any one term? And if you said 3, that would be the degree of this expression. Okay, we're going to go back now to our whiteboard. Now, if you saw an expression that looked like this, negative x to the fourth minus x to the second, let's say, this would be two terms. What would be the numerical coefficient of this term? Well, whenever there's just a 1 of something, by convention, we don't write the 1. But when we're doing computing, I think it's okay to put it in there. So the numerical coefficient of this term is a negative 1. All right, something to keep in mind. Now in your notes, you're going to write concept check. And you should write this statement down. If no number is written next to a variable, the coefficient is understood to be, and we just reviewed that, 1. Now, for number 2, what are like terms? So here you should pause, read all of these. You only need to put which one will be the answer. And it's this one here. Like terms are terms that are constant or terms that have the same variables raised to the same power. And remember, order is not important. If you have 2ab plus 5ba, these are like terms, even though the variables are in a different order. Now, for example 1, and you're going to write that, we want to identify the like terms. So scanning what we have, there's a 6 all by itself. So are any numbers by themselves? Here there's a negative 10.1, and then there's a 0. All right, let's look for the terms with just the x. Well, there's a 2.2x. There's a negative. Now remember, there's a negative 1x. We just don't write the 1. And when you put it into the software, don't put the 1 there if it's just a 1x. And here we have a negative 5x. Okay. Then I'll change colors. And then we have a 3x squared z. That would be one kind of like term. And then there's a fraction, 3/4 x squared z. That would be the like terms there. All right, so something rather easy to start off with. Now, with the background we have, we're looking for a strategy to simplify algebraic expressions by combining like terms. This is getting us ready for chapter 2, where we do equations, where that's one of the main things we do. So let's first of all look at what is an algebraic expression again. And you don't need to take notes on this, just watch and listen. So here, there's a negative sign separating this. This is two terms. What's the degree of this expression? Well, the 2. Now, this is just one term here because it's unified by that grouping symbol, the division bar. That's one term. And then plus y squared is another. So this would have two terms in this expression. Now, this one is just division bar grouping them together. Now, on the numerator part, there are two terms. In the denominator part, there are two terms. But because of this unifying grouping symbol, the division bar, this is considered just one term. Now here we had one like this already. This is 4 terms. The degree of this is 3, 2, 1, 0. And the degree of this expression now is 3. All right, we'll clear that up so we can get on to something like this. So I have BA plus CA. Now you may want to write this down. Now, if we were to factor this, there is a common factor of A in each one, and that would then become B plus C in parentheses, in a sense A, which is what they're showing here. So if B and C were like terms, we could add them together as they're showing here. Now, normally we don't go through this middle step. We see they are like terms. We're just going to add the numerical coefficient part. The variables don't change, and we get 9a. And similarly, 17y minus 14y equals 17 plus 14, or I should say minus 14, is going to give us a positive 3y, as they show here. Okay, this is background, so not necessarily taking notes on everything here. A summary statement that you may want to put in your notes. How do you combine like terms? We add or subtract the numerical coefficients and keep the common variable expression. We don't change the variable part or its exponent when we add or subtract. So in your notebook, you're going to write concept check. To combine like terms, add or subtract the coefficient and add the exponent of each to the common variable. Well, we don't add exponents, so this would be false. Okay, you will write these examples down in your notes, and this is example 2. So it says simplify each of these. Well, again, for A, 8x plus 10x will give us 18x. For B, and you're going to write this down. Now, you're subtracting the like term part, and that's going to be 4.2y plus 3. So 3 from 5 is 2, and 2 from 6 is 4. Yeah, that looks good. Now, as we look at example C, and again, I might ask as a quiz question, what did you get for example 2C? Well, this is what you would put, because here, the like term part is 3x squared, and 1x squared gives me 3x squared. And then a 3x minus a 1x is going to give me a plus 2x. Now, for this one, we have to do the distribution of what's outside the parentheses, which indicates multiplication. So we can do it together. This is 4n minus 28. Distributing this, and then plus 5n plus 5. Now we have our like terms. We have a 4n and a 5n gives us a 9n, and a negative 28 and a positive 5 gives me a negative 23. Now, as we look at example E, there are no like terms, so this is as far as you can go. That would be the answer to E in number 2. All right, now this one I'll write out for you. X plus 3x over 2 plus 5x. Now here, because of the grouping symbol, we have to do this first, which then becomes 4x over 2 plus 5x. Now here we can cancel. The 2 goes into 2 once, 2 goes into 4 twice. So we now have 2x plus 5x gives us 7x. And there are our answers. And if we were to go down, we'd see them all worked out. And it should match up here. Continuing on with some background information, that is, we're going to evaluate now algebraic expressions where we substitute a value for the variable. Now notice in general for x, as long as it doesn't equal 0, we have some interesting things that happen. So here we have a negative x squared. So whatever the value of this, the end result will always be negative because of this negative sign. Think of this as a -1 times this. Now, whenever we have as our base of an exponent is in parentheses, it is now a -x. Well, whenever this is squared, it's always going to end up being positive. And so therefore, this does not equal this. That is true. These do not equal each other. And we'll see that as we continue with our examples. We have a quick concept check again. You want to write this down. Now, do these equal each other? No, this is false. We just said that. When evaluating an expression that is not currently simplified, it is a good idea to simplify the expression before evaluating. Is that a good idea? And that is true. That is a good idea. And we'll see that as we move on as well. On to example 3, and we'll go to the whiteboard. We want a protocol for substituting our value for the variable. So here, you should set it up like so. And we're going to put in there a 3. And then later, set it up like so. And we're going to put in there a -4. So here our base is 3 that we're squaring. So this is 9. Now here our base is a -4 because of the grouping parentheses. -4 times -4 is a positive 16. Now here, note the difference. Here our base is only the x. And we'll set that up twice. So here we put the 3 for our variable and a -4 for our variable. Now notice when we square 3, we get a 9. But then we have to apply this, in a sense, -1 times 9 gives us a -9. Squaring a -4 we said was 16. But then think of this as -1 times 16 is a -16. Going back to our regular, and we see our answers here. All right, let's go on. Now this is example 4. And they're suggesting, and this is what you should do, is to simplify this expression first. So we have a 2x plus 7x gives us 9x plus 5. Now we're going to put the value -3 where the x is. So 9 times -3 plus 5. This is a -27 plus 5 gives us then a -22. And they have this worked out there as well. Now for example 5, again they're suggesting simplify first. So we have 3ab and a -4ab, which will give us a -1ab. Remember, we don't write the 1 normally, but for calculations it's okay. And here we have a 6a minus 1a gives us a plus 5a. So now we're going to substitute. -1. A, we said, was 2. B is a -1. And then plus 5. A is 2. So here we see in the string of factors, negative times a negative gives us a +1, times 2 is 2, and 5 times 2 is 10, gives us a total then of 12. So again, you want a protocol to substitute the value into the variable, and the use of parentheses I think is very important here. And this is our last example, example 6. And again, they want you to simplify. So 12x plus 5x, or I should say 7 plus 12, thinking ahead, 12x over 4, minus, distribute that, 2x minus 2. So here 4 will go into there once, 4 goes into there 3 times. So we get 3x minus 2x is 1x minus 2, and we're saying x is 5. So 1 times 5 minus 2, 5 minus 2 is 3. I don't know why I put that extra symbol there. There we go. And that checks out. Okay, this ran a little long, but again, lots of background, and you can always play it, any of these, faster, go back, and of course, review again.